In this question, it is given that the stresses on two perpendicular planes through a point in a body are 30 megapascal and 15 megapascal, both tensile, along with a shear stress of 25 megapascal. Find the first part, the magnitude and direction of principal stresses. Second part, the planes of maximum shear stress. Third part, the normal and shear stress on the planes of maximum shearing stress. So in this question, a stress element is given at which a 30 megapascal and 15 megapascal normal stresses are there, both are tensile, and a shear stress of 25 megapascal is available. And we have to find out the principal stresses and their direction, the direction of maximum shear stresses, the magnitude of normal and shear stress on the planes of maximum shear stress. So we have already solved this question using analytical method. Now we want to solve it using graphical method, which is also called Mohr Circle method. So let us solve it. Let us solve one more numerical based on Mohr Circle. We have already solved this numerical using analytical method, in which the stress condition was this: sigma x was given 30 megapascal, sigma y was given 15 megapascal, and shear stress was given 25 megapascal, and all positive. Right? It means the stresses, normal stresses are tensile, and tau is making anti-clockwise couple at the plane of sigma x. Right? And we have to find out minor and major principal stresses, plane of principal stress, shear stress, maximum shear stress, where the plane of maximum shear stress, and the magnitude of maximum shear stress, and the magnitude of normal stress at the plane of maximum shear stress. Right? This thing we have to find out. So let us make the stress element of this and then draw the Mohr circle. So, and remember the formulas. Center is given by this coordinate points, and radius is given by this equation, right? So let us draw the stress element for this first. This is our stress element, in which this is our sigma x, which is given to be 30 megapascal. This is the sigma y, which is given to be 15 megapascal, and this is the shear stress element here, and the applied shear stress is 25 megapascal. So this is our stress condition: sigma x 30, sigma y 15, and tau 25 megapascal. So this is our stress condition. So to draw Mohr circle, you need center and radius. So first of all, find out the center. Center is given by sigma x plus sigma y by 2. Sigma x is 30, sigma y is 15 by 2, and we are taking only the x coordinate. We are not taking y coordinate, because y coordinate is 0, so we are not taking here. So this is 45 by 2, so you will get 22.5. 22.5 is your center, the coordinate of the center, and only x coordinate we are taking. Now what is radius? Radius. So radius will be equal to under the root sigma x minus sigma y whole square by 2. So 30 minus 15 by 2 whole square plus tau square, that is tau is 25 square, and you will get the radius of the circle as 26.1 megapascal. So this is our center and radius, which will be used for making the Mohr circle, right? So first of all, find center and then radius. Now draw the Mohr circle. Both are positive. We are taking positive in this direction. So this will be our y-axis, tangential stress direction, right? This is our tangential stress direction, sigma t. This is our normal stress and positive in this direction, sigma n. And we have to draw the Mohr circle. First of all, take a scale. You can choose any scale which you want. Suppose 22.5 megapascal. You can take 22.5 megapascal to be 22.5 centimeter. Right? It's your choice, whatever you want to choose. So let us say scale 22.5 megapascal is equal to 22.5 megapascal is equal to 22.5 centimeter, right? Whatever scale you want to choose, you can choose. It is positive, so move on this side, take the scale till you get the 22.5 point. So 22.5 is suppose here. This is our 22.5, and draw the circle of radius 26.1. So open the compass and draw the circle 26.1. So let us draw the circle. Suppose this is our circle. First of all, I am drawing the circle there, and then suppose this is the circle. Suppose this is the circle. I have already drawn the circle, right? So this is the circle. Suppose draw the circle using your compass, and you will get this type of circle which will be cutting this axis. You will find that this will be cutting because I have already solved this question. So you will find this type of circle that which will be cutting the y-axis, right? So that there is some stresses in negative direction also. So you will try it and you will get this answer. So this is our center. This is center which is equal to 22.5 megapascal. So this line is, this distance is OC. OC is here. OC will be equal to this center which is 22.5 megapascal. 22.5 megapascal. This is the center, right? Here I am writing, this is OC and equal to 22.5 megapascal, and opening the compass equivalent to this radius, we can draw the circle, right? So it is okay now. Make the point A and B. Sigma x and tau will make the one point, and sigma y and tau will make the another point, right? So A point will be sigma x and tau, which will be equal to 30 and 25. It will be 30 and 25 megapascal. Another will be B point, which will be sigma y and tau, and that will be equal to 15 and 25. So locate the point on the circle and you will get the line ABC, right? So locate A point and B point. So A is 30, sigma x. Choose 30 here. This is 22.5, it will be higher than this. So 30 will be lying somewhat here. Suppose this is our 30. This is the 30 line, right? And suppose this is D. So OD will be equal to sigma x, which is equal to 30. So OD is basically sigma x, which is equal to 30 megapascal. Now shear stress at this point is 25. So 25 positive, we are taking positive in downward direction, sigma t positive in downward direction. So shear stress is positive in downward direction. So drop a vertical till you get the circumference of the circle, and this will be the this is the shear stress 25 megapascal. So DE is basically shear stress, which is equal to 25 megapascal, right? You will get this thing. DB, A, because this is A point, so we have got the point A. So now A point is located here, right? A point is located. Now our aim is to locate the point B. Here the value is 15. So take the value 15 from here. It will be less than this. Suppose this is our 15 value, and this is O, suppose E, OE. So OE basically sigma y, which is equal to 15 megapascal, and drop a vertical line till you get the circle, and it is keep it in mind that at B point the shear stress is negative, because on one axis it is positive, then another it will be negative. So here you will get the negative shear stress minus 25, because at this plane, if this at sigma x plane it is positive, it is making positive couple, then it is making a clockwise couple which we are taking a negative, so tau will be negative, so we are taking upward negative. So drop is vertical line so that you get the circumference of the circle in negative direction, right? So you will get this type of line, a vertical line, till you get this point. This is our B point. A point we have already achieved, so B point, and this is another point, right? And make a circle passing through the center, so you will get ABC line, which will be our reference line, which is our stress element, right? And here two planes have 90-degree angle, here it will be 180-degree, right? So A to B line, draw a line from A to B, and you will get this line, right? So passing through C point, so this is our C point, it is passing through point C, this is our C point, right? Is it okay? So this is our reference line, and this BE will be the shear stress again, which is negative shear stress. So BE is basically minus shear stress minus tau, which is equal to minus 25 megapascal, right? So we have achieved the line AB, we have got the line. Now what else is required? Principal stresses sigma 1 and sigma 2. You know that principal stresses lie on the plane where there is no shear stress is 0, and on x-axis, y-axis is 0, y coordinate is 0. It means at sigma n line there is no shear stress. So sigma stresses, principal stresses will be lying on the on this line where the circle is cutting this line, sigma n line. So circle is cutting the sigma n line at 2 points. Here suppose this is F, and here say it is G. So OF will be one of the principal stress and OG will be the another principal stress, right? And you will find that this will be towards negative side, somewhat negative side. So you will get the answer as, answer of this sigma 1 sigma 2 as sigma 1 will be equal to, that will be equal to OF, right? And by scale you can easily measure this OF, and you will get this value as 48.6 megapascal, right? Sigma 2 is negative, you can see here OG is negative, so you will get sigma 2 as OG, which is minus, you will get the minus sign for this, negative sign, so you will get 3.6 minus 3.6 megapascal as the minor principal stress, right? Now theta P, plane of maximum and minimum principal stresses, right? So this is plane this is plane, this is one plane, right? And this is our reference line, right? So move from this line till you get this plane OF line, right? So this will be our theta P, but in Mohr circle the angles are double, so you will get 2 theta P here, 2 theta P. So basically this angle ACF is the angle ACF, you will get ACF will be the 2 times theta P, because in Mohr circles angles are double, so it is 2 theta P ACF, right? Measure it by protractor and you will get the double of principal stress, right? principal plane, and if you find out from this, finding after measuring, you have to make it half, you will get the theta p, and the value will be 36.65. so theta p will be equal to 36.65 nearly when you measure it, and this will be the answer. So two answers we have already obtained. These are the previous answers we have already obtained, and one is this answer, theta p, right? Half of this angle ACF. Now theta S, maximum shear stress. Where the maximum shear stress lies? The maximum shear stress lies in vertical direction where we reach the extreme point of the circle. So in vertical direction, when we move vertically downward or upward, we will get this point, and this is our maximum shear stress plane, C to suppose H. So CH will be the maximum shear stress, because maximum shear stress is in vertical direction, we are taking positive downward. So maximum shear stress is CH, and this is the plane of maximum shear stress. When you move your protractor in this direction, you will get the plane of maximum shear stress, and this angle will be double of the shear stress in actual condition, right? So we will get 2 theta s here, and because it is clockwise, so it should be negative, and anti-clockwise we are taking positive, so we have moved clockwise. So angle HCA or ACH is basically 2 theta s. So angle ACH is our required result, that is equal to 2 theta s, twice of the angle of shear stress, right? By this, take it half of this and you will get the answer, and that will be minus 8.35. So theta s will be equal to minus 8.35 degrees. We have already solved by analytical methods, now we are solving by graphical methods. 8.35, right? And minus because we are moving clockwise now, right? Anti-clockwise we have taken positive. Now what else is required? Sigma t max, this value, right? The radius of the circle, you can say radius of the circle, this is the maximum value, right? And radius of the circle is already found out, 26.1, and same is the shear stress maximum. So sigma t max is basically, our radius of the circle, which is equal to 26.1 megapascal. Plus minus you can take 26.1 megapascal. This is one more answer. And next is sigma ns. What is the value of normal stress? At the plane of maximum shear stress? So this is our plane of maximum shear stress, right? And the normal stress is this, starting from origin to moving from O to C. O to C is basically the principal stress at the plane of maximum shear stress. So this value is OC is the CNS, sigma ns. So this is 22.5 megapascal. So already this is the center. Basically this is the center, OC. So basically this is center as well as sigma ns. So we can write also here sigma ns. Normal stress at the plane of maximum shear stress, sigma ns. And sigma ns is given by, this is basically the center, coordinate of centers, right? X coordinate of center, and that is equal to 22.5. So this will be plus minus 22.5 megapascal, right? In this case it is only plus, so we can write 22.5 megapascal. So this is the one more answer. So these are the answers for this Mohr circle method we have obtained using the graphical method, and you have chosen the scale. You have to choose the scale for that, so that it will be convenient to draw the circle, right?